Solve the given system of equations by using Gauss elimination method. Okay. So x plus y plus z plus w is equal to 3, 2x minus 5 plus 3z plus 0 w is equal to 3, 2y plus 3w is equal to 5 minus x plus 2z plus w is equal to 6. Now we have to find the values of x, y, then z and then w. Okay. So by using Gauss elimination method, first we have to write the coefficient of the given equations as a is equal to coefficients 1, 1 and 1 and another 1. The next 2, coefficient of x is 2, coefficient of y is minus 1, the coefficient of z is 3, and there is no w term, so coefficient of w is 0. At here coefficient of x is nothing, so if you take as 0, coefficient of y is 2, so take 2, then coefficient of z is nothing, so we have to take 0, and coefficient of w is 3, take it as 3. Next the last equation, coefficient of x is minus 1, coefficient of y is nothing, so take it as 0, then coefficient of z is 2, coefficient of w is 1. So this is the A matrix. Next the X matrix is, which is unknown to us. Unknown values are what? X, Y, Z and W. So write in column form like this: X, Y, Z and then W. Next RHS values, we have to take it as B. This is also column matrix: 3, 3, 5 and 6. Take it 3, 3, 5 and 6. Now write the matrix. The given system of equations can be written as Ax is equal to B. So we have to write in Ax equal to B form. So here A is this one, A is 1, 1 here. Note the same thing at here in the form of Ax equal to B. This is A, 2 minus 1 3 0 0 2 0 3 minus 1 0 2 1. This is A, and the next X is X, Y, Z, W, and B is 3, 3, 5 and 6. This is B. So now we can write this matrix in the form of augmented matrix. Augmented matrix is Augmented matrix is nothing but the combination of the A matrix and the B matrix is known as the augmented matrix. That is A partition B. Right here augmented matrix A partition B, and then right here 1, 1, 1, 1 and then partition 3. Next 2 minus 1 3 0 partition 3. Next 0 2 0 3 partition 5. Next minus 1 0 2 1 partition 6. Now in Gauss elimination method, we have to find the values of x, y, z and w by first we have to get the in the form of upper triangle matrix. Upper triangle matrix is nothing but below the, this is the principal diagonal elements, 1 minus 1 0 and 1 are known as principal diagonal elements. Down of these elements, this one, this 2 0 2 minus 1 0 2, this all has to become 0, so that this matrix is said to be as a upper triangular matrix. So we have to make 2 0, this 2 1 minus 1 0 2 as 0. So first make this 3 as 0 by using the first one. We have to use only row operations in the Gauss elimination. Same matrix has been written at this page, so we have to make first this as 0. So let us make this as 0 by doing the row operation. R2 tends to R2 minus 2R1, so that 2 minus 2 into 1, 2 minus 2 is 0, so that we get here as 0. Now let us make it. Keep R1 as same, 1 1 1 1 and then 3. Next R2 is R2 minus 2R1, so 2 minus 2 into 1 is 2 minus 2 is 0. Next minus 1 minus 2 into 1, so we get minus 3. 3 minus 2 into 1. 3 minus 2 is 1. 0 minus 2 into 1. So minus 2. 3 minus 2 into 3. 3 minus 6 is minus 3. So now this is already 0. So let us write this as same. 0, 2, 0, 3 and then 5. Now we have to make R4 as 0. So R4 can be made 0 as like this. R4 tends to R4 plus R1. So that minus 1 plus 1 gets 0. So let us write R4 also. Minus 1 plus 1 is 0. 2 plus 1 is 3. 0 plus 1 is 1. 1 plus 1 is 2. 6 plus 3 is 9. Now we have to make this as 0, this as 0 and the next this as 0. This 3 has to be done 0. Now first let us do this one as 0 by R3 tends to. We have to do this as 0 such that this has to not change. This will not change when we use these both rows only. If you multiply 0 with any other number and add with this, so there will be again 0 only. So that this numbers does not even change. So we have to use only row 2 for making this element as 0. So that R3 tends to 3R3 plus 2R2. So let us do this. Write first row and second row same. 1, 1, 1, 1 and 3. 0, minus 3, 1, minus 2, minus 3. And then next R3. R3 is 0 into 3, 0 plus 2 into 0, 0. So here you get 0. We have to get only 0 at here. This has to not change again. So we have to only use row 2 operation only to get this as 0. We can use row 3 also, but with row 2 we get easily. Use only row 2. Do not use row 1. If you use row 1, we get another value at here instead of 0. So let us do another one. 3 2s are 6 plus minus 6 is 0. Next 3 into 0 is 0 plus 2 into 1 is 2. So here 2. Next 3 into 3 is 9 minus 4. 9 minus 4 is 5. Then here 3 into 5 is 15. 15 minus 6 is 9. So now R4 also should be done 0. So we have to add this both so that 0 also does not change. So such that 0 plus 0 is 0 and 3 minus 3 is 0. So let us do R4 tends to R4 plus R2. We do another operation here. R4 0 plus 0 is 0. 3 minus 3 is 0. 1 plus 1 2. 2 minus 2 0. 9 minus 3. This is 9 minus 3. 9 minus 3 is 6. So we have to make this as 0 now. So let us use this one. R4 tends to R4 minus R3. R4 tends to R4 minus R3, so that this becomes 0. Let us write all as same. 1 1 1 1 and 3. 0 minus 3 1 minus 2 minus 3 0 0 2 5 9 and then minus R4 tends to R4 minus R3. So 0 minus 0 is 0. 0 minus 0 is 0. 2 minus 2 is 0. 0 minus 5 is minus 5. 6 minus 9 is minus 3. So now this all has become 0. So now we'll write again the equations. These are the coefficients of x. These all are coefficients of y. These are coefficients of z. These are coefficients of w. So these are RHS part. So let us write here minus 5z is equal to minus 3. Minus 5z is equal to minus 3. The next minus 5w. Minus 5w is equal to minus 3. This is 2z plus 5w. 2z plus 5w is equal to 9. And the another equation is minus 3y plus z minus 2w is equal to minus 3. And the last equation is x plus y plus z plus w is equal to 3. So here we get w as 3 by 5. Let us substitute this at here. This is equation 1. This is 2. This is 3. This is 4. Let us substitute this w in equation 2. So we get 2 into z plus 5 into 3 by 5 is equal to 9. 5 gets cancelled, and 2z is equal to 9 minus 3 is 6, z is equal to 3. Let us substitute z equal to 3 and w is equal to 3 by 5 in equation number 3. So we get answer as minus 3y plus 3, next minus 2 into 3 by 5 is equal to minus 3. So let us calculate this. Minus 3y plus 3 minus 6 by 5 is equal to minus 3. So minus 3y plus 15 minus 6 by 5 is equal to minus 3. So minus 3y plus 9 by 5 is equal to minus 3. So minus 3y is equal to minus 3 minus 9 by 5. That is equal to minus 15 minus 9 by 5. That is equal to whole by 5. So we get minus 24 by 5 is equal to minus 3y. Cancel minus minus, 3 ones are 3 eights are. We get y is equal to 8 by 5. So let us substitute this y value, z value and w value in equation number 1. So that we get what is equation number 4? We substitute equation number 4. X is unknown for us. X plus y is 8 by 5. The next z is 3, w is 3 by 5 is equal to 3. So let us write this all. X plus 8 by 5 plus 3 by 5 is 11 by 5, and the next here 3 gets cancelled, is equal to 0. X is equal to minus 11 by 5. We got the values of x, y, z. The values of x, y, z, w are x, y, z, w are minus 11 by 5, 8 by 5, 3 and then 3 by 5. Let us verify these values are correct or wrong. Let us open the question. And from question, the first equation let us see is this: x plus y plus z plus w is equal to 3. Let us verify that equation. X plus y plus z plus w is equal to 3. Now let us substitute the values of x, y, z and w, so that we have to get the LHS part after adding all as 3. If we get LHS part after adding all as 3, then our answers are correct. So let us do it. Minus 11 by 5 plus 8 by 5 plus 3 by 5. What is minus 11 by 5 plus 8 by 5 is minus 3 by 5. Minus 3 by 5 plus 3 by 5. Minus 3 by 5 plus 3 by 5 gets cancelled. We got 3. This is LHS part. And the RHS part is also 3. So that LHS is equal to RHS. Our answers are correct only. X is minus 11 by 5. Y is 8 by 5. Z is 3. And W is 3 by 5. So this is the Gauss elimination method of 4 by 5 matrix.